This is a piecewise function. And in this piecewise function, we were trying to figure out where is it continuous. Let's start with this top piece. The top piece, sine of 6x over x. For that function, you can plug in whatever value of x you want except x equals 0. But that's okay because it's not defined at x equals 0. So because you can plug in whatever value of x you want without fear of it dividing by 0 or taking the square root of a negative like that, or taking the log of a negative for that matter, it's continuous everywhere you want to except possibly at 0. Now, what about this guy? What does this do? Well, here's what this graph looks like. This sine of 6x over x, it's some wacky sine curve, and then there's a hole here. Now, the question is, what is the value of that hole? What's the y value of that hole? This would be a hole, and therefore discontinuous, if the value here doesn't plug it in. So this hole here, that's like hole in the boat of a ship. We want to make sure that we seal that hole, and if it is sealed, then it's continuous everywhere. If it's not, then it's not continuous at x equals 0. So how can I figure out what the y value of that hole is? Well, this is just taking the limit as x approaches 0 of sine of 6x over x. If you might not know this form, but let's do it over here in pink. There's a certain form you need to know, that is the limit as x approaches 0 of sine of ax over bx. This value comes out to be a divided by b. So long as you have this form, that limit is free. Now, turns out we have that same exact form over here, sine of 6x over x, and limit as x approaches 0. Note that a is 6, b is 1, even though you don't see it, and so we have 6 divided by 1 is 6. So the corresponding y value of that hole is 6, and hey, that gets plugged in by this value here. If this had been some other value, then it would not have been continuous at 6, but because this value is 6, it's continuous everywhere.